Okay, section 1 is determining if there's a difference between the average of group 1 and the average of group 2 when you know the population standard deviation of the two groups. To me, this isn't real realistic, but I'm going to show it to you because every textbook does. So in this section, we're going to work problem number 8. There's two different ways to work these, and I'm going to show you the way the textbook has you do it, which is a lot more handwork, and then I'll show you how to do it on the computer. And the computer, there may be some of the problems in this section you can do on the computer, but so we're going to look at number 8, which is talking about the difference between Arnold Palmer and Tiger Woods. This is on page 407. To show if there's a difference between these two golfers and how they're playing in their top games. It just says the following sample provides an 18-hole scoring during the PGA tournament competitions from his 1960 season for Arnold Palmer and 99 season for Tiger Woods. And it shows you that the sample size of Arnold Palmer is 112 games, and his average score was 69.95. And for Tiger Woods was a sample of 84 games with a sample mean of 69.56. And then it says, use the sample results to test if there's a difference between the two population means. And it says, assume a population standard deviation of 2.5 for both golfers. What is the value of the test statistic? So we're going to use the formula on page 402 to calculate the z-value for this. And I'm just going to show you quickly here instead of having to write it all out, because that will take quite some time. Here is what the formula should look like. Okay, so if you need to pause this, feel free. But you can see the mean of group 1, 69.95, minus the mean of group 2, 69.56, minus the hypothesized difference, which is 0, because we're just trying to see if there's a difference, divided by, and then you do the variance of group 1 divided by the sample size plus the variance of group 2 divided by the sample size. And when you compute that, you get a z-value of 1.08. And now we want to compare that to our p-value, because part 2 of this, so that's the answer to A. That's the test. Part B says, what is the p-value? So we want to go and look up this z-value in our z-table. And when you look up 1.08 in the z-table, you get a value of 0.8599. Okay? And remember, if it's a greater than, you got to say 1 minus that to get the little tail. So we're going to say 1 minus that to get our little tail area. Okay? And then because it's a two-tail test, because it's equal to, we're going to say 2 times that to come up with a p-value of 0.2802. And page 403 gives you a good example of how to work through one of these. Okay? And then because 0.2802 is greater than 0.05, we do not reject the null hypothesis. So we accept the null hypothesis. And so we which shows if you accept the null hypothesis, there's not a difference between the two. If you reject the null, then there is a difference between the two. So that's how you work problem 8 on this chapter. I'm going to come back and show you the way you do it on the computer, which I like a lot better.